In this video, you will learn about functions and how to determine if a relation is a function. A function is a relation in which each member of the domain is paired with exactly one member of the range. All of the x values in a relation must be different for the relation to be a function, is one way to test this. The other way to test this is that the function must pass the vertical line test. A vertical line will pass through the function only once, no matter where it's positioned. So if we look in the example on the left, this vertical line passes through the function once. For the other two examples, the vertical line passes through it twice, so it's not a function. In our first example, it says determine whether the relation is a function. So for the first example we have here, we can see that the x value of 4 is repeated. So the relation is not a function because the x values are repeated. For our next example, we can see that each x value is only listed once. Since it's only listed once, we could say that yes, it is a function. In the next example, it says to use the vertical line test to determine whether each graph represents a function. As I pass my vertical line through this example, I could say that it first crosses twice right here. So since it is crossing the vertical line twice, it is not a function. In our next example, as I move my vertical line through, at each point it's only crossing this line once. Since it only crosses once, I could say that yes, it is a function. For the last example, if I were to move my vertical line through, when I hit this first spot, I have that I'm passing through it twice. Since it's passing and touching the vertical line twice, no, it is not a function. In these next examples, we're going to do the same thing. So for my first one, if I move my vertical line through, it only touches once at each point. So this would be, yes, it is a function. In this next example, if I were to move my vertical line to this point, it is crossing it twice. So this would be, no, it is not a function. For the next example, if I move my vertical line, it crosses at each point only once. So I could say that, yes, this is a function. For the next example in the bottom left, as I move my vertical line, it only crosses it once. So I could say that, yes, it is a function. For the one in the bottom in the middle, as I move my vertical line, once I hit this point, it is crossing it more than once. At this point, it's actually crossing it 3 times. So it'll be the answer that no, it is not a function. Finally, for our last example, if I were to move my vertical line across, it only passes it once at each point. So I could say that, yes, it is a function. The last part of this section is function notation. So normally we say that y equals some sort of an expression. Instead of saying that y equals, we can instead say that f of x equals the same thing. Basically, all we're doing is replacing the y and rewriting as f of x. The x is whatever we're going to substitute into the equation. So if it says to evaluate f of 4, this means to find the value of the function where x equals 4. So if my function were that f of x equals 3x plus 5, this means that since I'm saying it's f of 4, I'm going to rewrite it as 3 times 4 plus 5. So I'm just replacing the x over here with a 4. And now I would simplify. So 3 times 4 gives me 12 plus 5. And it simplifies to 17. So I could say that f of 4 equals 17. For our final example, we're going to use the function f of x equals x minus 4. So if I wanted to rewrite f of 2, I could say f of 2 equals 2 minus 4, which simplifies to give me that f of 2 equals negative 2. For b, it's asking us for f of 1/2. So I substitute the 1/2 in for x. So it becomes 1/2 minus 4. So it gives me that f of 1/2 is negative 3.5. Lastly, for c, I could say it's asking me for f of c. So I replace the c in for x. So it becomes c minus 4. And since c is a variable, we can't simplify any further. On this last slide, it gives a summary of our function notation and the types of variables that are related to each.